Hello and welcome. This is the Open Wi-Fi project, the dawn of the free Libre Wi-Fi chip talk by Xianjun Jiao. So Xianjun works on SDR implementation of Wi-Fi wireless networks at IDLab. He is also an active free software SDR developer on LTE, BTLE, GPS, ADSP, and Wi-Fi. In this talk, he'll introduce the Open Wi-Fi project, a key piece of the free software and hardware puzzle that aims to enable fully free connectivity. Xianjun, please take it away.
Thank you. Hello, everyone. This is Xianjun Jiao. Okay, although I cannot see you, but I will try my best. I'm now working in IDLab, which is a joint lab between IMEC and Ghent University, Belgium, and I am Chinese. Today, I will talk about the Open Wi-Fi project, the dawn of the free Libre Wi-Fi chip. All right. So first, I need to answer the essential question. What is the Open Wi-Fi project? I list some items. It's a free Wi-Fi baseband chip design, although currently it's still a IPGA. Currently, it supports 802.11, 8G, and N. But some of you might be familiar with Wi-Fi 4, Wi-Fi 5, Wi-Fi 6. Currently, we support until Wi-Fi 4. And our hardware description language source code is available under 8GPL v3. And the design currently tested on IPGA against commercial Wi-Fi chip, which means that with our design running on IPGA, we can communicate with those commercial Wi-Fi chip, which means those your electronic devices, your home Wi-Fi router. Our design is compatible with all these standard or commercial Wi-Fi chip. And work in progress is Wi-Fi 6, i.e. 802.11ax. And the last row is the GitHub link of our project, but you don't need to remember this long address. You just search Open Wi-Fi on internet. I believe our GitHub address is on the top. Here is a brief timeline of our project. At the beginning, we did the internal development around 2 or 3 years in a European research program. It's part of the program. We also use the work for the research, for our internal research. And at the end of 2019, we decided to put the project online. And I also push a Twitter about the project with a very simple video. And as you can see, lots of people react. We got lots of attentions and eyes, and you will know why later on. I will explain. And right after that, in the February of 2020, we went to the FOSDEM in Brussels to give some demo in the stand and give a presentation. Also got lots of eyes attractions. And then you know what happened, right? The time is oh, sorry, I quit the full screen. Okay. The first time is in 2020 February, and then in March here the Belgium went to lockdown. So I tweet another Twitter, time to pack walls and go home. I work in home. Thanks to Corona, I will have a quiet month for Open Wi-Fi development. It turns out not a quiet month. It's a quiet year or years. We still don't know. Today here, I think working home or remote working is still mandatory if possible. Then I found a very interesting research on during the pandemic from Hofer, Germany. They found that this is the 2020 March, right? You see, when the lockdown begins, the internet traffic grows immediately. I think that's reasonable. Actually, the lockdown or the work at home convert all the traditional traffic by car, by train, by airplane to internet traffic. Because before the lockdown, people need to take those traffic, train, bus, airplane to do the conference. But after lockdown, we use internet traffic to do the conferences like we do now, right? So I think that's reasonable. So I believe everyone during the past year, you use Wi-Fi a lot, right? Every day. Okay. Even before the COVID, I also believe you use Wi-Fi every day. There are lots of Wi-Fi devices around you, your personal device, your home Wi-Fi router. So today, let's talk about the Wi-Fi chip that handles your daily internet traffic at home or at office. So the first thing I want to introduce to you is about the Wi-Fi chip itself, not about our project, because to have you a better understanding of our project, I need you to understand the Wi-Fi chip itself. The introduction will be a bit technical, but don't worry, I will make it easy for you. So what is a Wi-Fi chip? Wi-Fi chip is the yellow square here on my screen. The Wi-Fi chip, there's an antenna connected to the chip, and there's a bus or like the USB or PCIe. Anyhow, there's an electronic connection from the Wi-Fi chip to your operating system or to your computer. Computer could be an embedded computer like Raspberry Pi or your desktop or your laptop. And in your operating system, there should be a Wi-Fi chip driver. Otherwise, the operating system cannot recognize your Wi-Fi chip. And above the Wi-Fi chip driver, there's a network stack, right? Like the TCP/IP, etc., UDP, etc. So basically, Wi-Fi chip is a block with an antenna and with a connection to your computer. So how the Wi-Fi chip serve your app in your computer? Like the Google search or Facebook or Twitter. Here, the computer could also be your cell phone, your pad, right? Because cell phone, pad, basically they are computer. They are ARM processor-based computer. And how Wi-Fi chip serve your app? Actually, the basic philosophy is also quite simple. Those apps generate the data packet and handle the packet to your network stack, and then operating system put the packet from the network stack to your Wi-Fi driver. Driver put the packet to the Wi-Fi chip. After some processing, the packet is turned to a signal, wireless signal, and sent out via the antenna. On the other path, the receive signal goes to the reverse way. The antenna from antenna to the Wi-Fi chip. After demodulation, after lots of processing, the signal is converted back to the data packet, handled to the Wi-Fi driver, network stack, and finally reach your app. So that's the thing happens thousand times per second when you are using your computer with those internet app. So now let's go deeper. What are inside the Wi-Fi chip? As you can see, okay, I already introduced your app operating system. Now let's take a close look into the Wi-Fi chip itself. Inside the chip, actually there are two big building blocks, the baseband and the radio. The baseband basically is a digital part that handle your packet, convert your packet to digital signal or demodulate the digital signal back to packet. And the radio is the analog part. The radio could convert the digital signal to a real signal in the air, or convert the real signal in the air back to digital by the ADC and DAC. What is ADC? What is DAC? ADC is the analog to digital converter. DAC is the digital to analog converter. So I guess that's quite easy to understand, right? Inside Wi-Fi chip, there's a digital part, analog part, and digital analog converter. So the main processing is inside the baseband or the digital part. The main tasks of this baseband are three. The first one, packet queuing. Because when try to send the packet to the air, the packet firstly will be queued in the baseband. It won't be sent immediately. Remember, the air is open, the wireless channel is open. You should be polite before you send something. I will introduce later. That's quite interesting. The second part is the packet signal conversion, right? Modulation and demodulation. But if you don't understand modulation, demodulation, that's okay. Basically, it does the packet signal conversion. And the third part, most important part, avoid interference with other nodes. I will go to that in detail. That's about, you should be polite when you send signal in the air. So here I give you a quite example. You will understand very easily. I won't go into these building blocks in very detail. Basically, this building block is the baseband, right? I just mentioned it has three tasks: packet queuing, packet signal conversion, and avoid interference with others. So basically, the packet sending, like you are talking with your mouse here. And meanwhile, you should also listen to the channel. Who else is talking? It's like your ear, right? So there's some module that could listen the channel to make sure you won't interfere other people. So this is the very basic model of how Wi-Fi chip avoid interference with each other in the air. Okay, so what is the rule when your Wi-Fi chip or Wi-Fi device do the signal transmission and reception? Actually, the rule is very similar to this model. Imagine there are lots of people in a very busy room to do some ad hoc discussion between different peoples. Then the room is like the public Wi-Fi channel. As some of you might know, there are two Wi-Fi bands, right? 2.4 gigahertz, 5 gigahertz, and in the bands there are lots of Wi-Fi channel. And in one channel, the model is quite similar to this. Many people doing ad hoc discussion in a crowded room. Okay, so that's because in your home you have lots of electronic devices. Many of them has Wi-Fi chip. So actually, it's also a real model. In your room, lots of Wi-Fi chip. They need to communicate with each other randomly, according to what kind of app you are running on your Wi-Fi nodes, right? So those are basic rules. Listen before talk. And fast ACK to release the channel. What's the fast ACK? ACK means acknowledgement. Means that if someone say something to you, you should give him acknowledgement immediately to tell him, got it, I understand. Then your this time conversation finished. Then other people can use the channel immediately, right? You shouldn't think for a long time. When someone say something to you, you think for 1 minute. After 1 minute, you say, okay, I understand, got it. Then all other people need to wait for your thinking. So you should give a very fast acknowledgement to the other side. Got it? Okay, we release the channel. Other people can use it. The third rule, wait for random time after the channel is released or after you are interrupted. What does that mean? Because as I said, right, if some others are saying something, when they finish, right, they give acknowledgement, this conversation finished. all the people around will know, okay, these two guys, they finish discussion. Then can I speak now? If all people jump in immediately, right, they will interfere each other. So that's a very smart and simple and effective way. Even the channel is released. Now, silence. Now, you shouldn't talk immediately. You wait for a random time. And when you are talking, if you are interrupted, that means in the channel, some interference is happening. You should also wait for a random time. You shouldn't retry immediately. That only make things worse. And the next rule is grab the channel by talking. Okay, after you're waiting random time, your random timer is up, you can talk. Now you announce the channel is yours. You are talking. Other people will listen. Remember, listen before talk. And you can also grab the channel by announcement, by announce your plan via some special packets. When will that mechanism be used? It will be used when you have a long speech. You won't say a 10-word sentence to the other people. You have lots of words to say. Okay, before your lots of words, you should make an announcement. I will say for next 3 minutes. Now is the speech, blah, 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 blah. Other people will wait silently after you finish your long speech. That's part of the protocol. And you should shut up if other one is talking, right? Listen before talk. Or other one announce occupation for next period. During that period, if you hear the announcement, you should keep silent. I believe this rule, how Wi-Fi chip operate, coexist with each other, is easy to understand, right? So let me give you some real example, real Wi-Fi chip example. But you should be aware that all this information are from internet, from the community work by reverse engineering or some datasheet. Here is a recent Wi-Fi chip. It's a BCM 4339. What is inside the chip? Actually, the module are quite similar to my introduction. As you can see, there's an ARM processor in the chip, ARM Cortex processor with ROM RAM, and below the RAM, this ARM processor handling the packet handling, queuing, etc. And below the ARM, there's a D11 core. The D11 core is another processor that is handling those rules I just introduced. And then after that is a 802.11 PHY physical layer. This module do the packet signal conversion between signal and packet. Then finally, before go to the antenna, there's a radio. This is a real chip, real Wi-Fi chip in the real world. So as you can see, there are processors, right? The ARM processor, D11 processor, and those processors, some program are running. So they are called blob, firmware. Okay, I can tell you for this chip, some people did very great reverse engineering work, and because there's no free firmware for ARM, no free firmware for the D11 core. And the D11 core, if you check the datasheet, well, they have introduced the D11 core in the datasheet because for the Wi-Fi driver, you need to configure some register to configure some behavior of the low level. Anyhow, basically it's a CPU. You just need to remember that. This is one example. Another very good example is about of the Wi-Fi chip is AR9271. Why I say this is a very good example? Because the vendor Atheros has published the free firmware for this Wi-Fi chip. As you can see, the architecture is quite similar to the previous one, but unfortunately, this chip has discontinued. It's too old. But inside the chip is quite similar. The CPU, CPU and RAM, and ROM, etc., and Mac processor, which is handling those rules I introduced, and the PHY, right, do the packet signal conversion. And the vendor has released the free firmware on the CPU. That is very good. So from Linux perspective, you have a free driver, also free firmware. But I have to point out a thing is that this Mac processor, inside the Mac part, there are also lots of processor-like unit, like this DRU, QCU, TCU, PCU. Those U is unit like the CPU. For this part, also some program is running. This part, they probably won't run the C program or or some high-level language program. They run the very tiny program. They call it microcode, I think, in most of the Wi-Fi chip data sheet, microcode running on this part. But this microcode, microprogram, there isn't a free version, or you can't find the source code. So as I said, the community has did lots of work on the Wi-Fi chip, right? For instance, in those hardware project of free hardware boards, they are still using the commercial off-the-shelf Wi-Fi chip, like those very recent BL602, ESP32, ESP Wi-Fi module, Arduino, Raspberry Pi OpenWRT, the Pine computer or Pine device, and also RISC-V version of Raspberry Pi like Pico Rio, Pico V, etc. All these very hot hardware projects are using commercial off-the-shelf Wi-Fi chip, and most of the chip running the non-free firmware and non-free microcode, microprogram. Lots of reverse engineering is done for the firmware. If people try to develop the driver, people need to understand the firmware, the behavior of the chip. And there's a wiki that does the comparison of open source Wi-Fi driver. You can see most of the vendors offer source code of the driver. Yeah, that's reasonable because driver is part of the Linux kernel. It has to have the source code. And no vendor offers source code of the firmware except that chip AR9271 from Artheris. And no vendor offers source code of the low-level program. Like I mentioned, in the D11 core or the Mac processor of the Wi-Fi chip, that part handle the very time critical, those polite rules to make sure the Wi-Fi nodes can talk with each other. So far I don't see any vendor offer source code of that part. And okay, another interesting thing about Wi-Fi chip is about sensing. Actually, the Wi-Fi chip not only can do communication task for you, because in the air full of the Wi-Fi signal, actually there are already lots of work that use those Wi-Fi signal to do sensing, like sense the human gesture or sense the object around. The very early work you could find is like the seeing through wall from MIT Media Lab. And to use Wi-Fi signal for sensing, a standard is also ongoing. Standardization is also ongoing. It's 802.11bf part. This sensing, they don't need you to cooperate with the sensing because Wi-Fi signal is everywhere. They only need to collect those signal, right, from the air. Then you can sense people or object around. You can find lots of technology over there, together with the machine learning or AI. So Wi-Fi signal, besides carrying your internet traffic, the signal could also be used for detecting things around. It could be used for safety reason. It could also bring some privacy concern. Okay, let's do a quick recap. About Wi-Fi chip. The chip is small, cheap, yet complicated. How cheap a Wi-Fi chip is? I think you can buy a Wi-Fi chip with $0.50. The real cost, I think, is around 0.2 or $0.3. And the program, firmware, microcode is involved heavily in the chip. So this part, in my opinion, they are also software. The chip and program inside are non-free. And some types of the packet is generated on chip, like the acknowledgement, like the announcement I introduced before. Those are not generated by your app or by operating system. They generate by chip itself. So the chip could generate extra packet to, the purpose is to maintain the networking, the wireless public wireless networking operation without creating lots of interference. And the chip can see or sense the object around. It's a very hot topic right now. And people are so used to the commercial off-the-shelf Wi-Fi chip. Live with what is offered, black box chip and a free driver. Most of chip has the open source free driver. And reverse engineering, if people want to do more on the chip, or if people want to know more about the chip, people do the reverse engineering. That's the situation right now. Then jump to our project. Actually, I have to say, we are not aware all of the above Wi-Fi chip stuff before 2020, because before 2020, we are busy with our Open Wi-Fi project. But after our project is online, and many information and people comes to us, and we realize, then we start to see the commercial Wi-Fi chip ecosystem, what community has done, and we realized all the above situation. But before 2020, we didn't realize. But why do we do the open Wi-Fi? The initial reason is needed by our own research activity. And we also feel it's very useful for the broad research community, like other university or research institute. For instance, the researchers could implement innovative idea at the driver level and above. But when the idea comes to the chip level, it becomes impossible or very difficult. Reverse engineering needs luck. And students learn Wi-Fi knowledge in classroom, right, in the wireless network or in the communication technology lessons, but they never see the devil in the details, the design inside a Wi-Fi chip, because no free design available for there to watch, for there to see, to learn. And access the commercial Wi-Fi chip design, source code is very expensive with many limitations, NDA, license, etc. So that's the initial reason why we do the Open Wi-Fi project. Because we feel we have enough expertise and knowledge to develop a Wi-Fi chip. So we decide to go for it directly instead of reverse engineering. Those are two roads. I think both roads are okay, but we choose the forward one, direct one. We design our own Wi-Fi chip, and then we know how Wi-Fi works. So after realizing the situation of the non-openness around the commercial Wi-Fi chip, we believe that now the Open Wi-Fi project could mean more. Because Open Wi-Fi is the first free HEPL v3 chip design 20 years after 802.11 was released around 2000. As you can see, this page is from Wiki around around 1999 or 2000, the 11BA very first Wi-Fi standard was released. Now it's 20 years later. The 11B, 11A, they are still being used. But Open Wi-Fi is the first free design 20 years after. Open Wi-Fi, we have achieved a lot, achievement and impact. For instance, we have monitored lots of users on the internet via the GitHub, lots of university and research institutes all over the world, in US, in Asia, Europe. And we also did a good job on the GitHub regarding the stars, forks, watch, etc. You can check by yourself. After all, we are the first free design. Before us, to access a Wi-Fi free design is very expensive or very difficult. So the project initially funded by the European Horizon 2020 ORCA project, as I said, our internal development at the beginning. And we also got 50K euro from Net Foundation for the Wi-Fi 4 feature, which was released already in the FOSDEM 2021. Yeah, we go to FOSDEM, and you can also find lots of discussion on the internet about the Open Wi-Fi project. So one interesting thing, well, when you have open and free design, some amazing work, some more amazing, more innovative work could happen. Here is an example. As I said before, the Wi-Fi signal can be used to sense the people or object around, right? The basic principle is that by collecting Wi-Fi signal, they can do the channel estimation, channel between the transmitter and the receiver. Receiver is non-cooperative receiver. Anyone can receive Wi-Fi signal. After receive Wi-Fi signal, they can estimate the channel between transmitter. The transmitter could be your device, could be your home router. The channel between transmitter and receiver. By estimating the channel, they can make a guess on the object or people in between. So in this work, the CSI murder, this is from Open Wi-Fi users, external users, not from us. They developed a technology that could anti-sense. The basic principle is also simple. As we own the design, right? It's a free design, so we can change the design. We can add the fake or random channel before the signal leaves the transmitter. Then at the receiver, you see a real channel plus fake channel. So all your sensing algorithm will not work anymore. Then user could take control. If the user want the sensing work, well, we can turn off this random or fake channel generation in my Wi-Fi device. If I don't want other people to do sensing around me, I can turn it on. So that's a very good, interesting, inspired by the Open Wi-Fi, open and free design. Okay. Okay, we are approaching the end. Use Open Wi-Fi as your home AP. It's quite simple. 3 steps. The first step, you buy an IPGA board. It's not from us. It's off-the-shelf IPGA development boards. And download the Open Wi-Fi image to SD card. Insert the SD card to your IPGA boards. And connect Ethernet cable from your IPGA boards to your home router, to your home broadband router from your operator, right? Then because the router is connected to the internet via ADSL or fiber. And power on. Then you will see a SSID called Open Wi-Fi from this IPGA AP. Because currently we don't have real chip, it's IPGA. Now you have Open Wi-Fi AP in your home. You can use it every day. What's next? from our project. We have some thoughts, and we also would like to discuss with many of you. The FPGA board is flexible. We can still improve or fix the design, but FPGA board is very expensive, from 800 to 3000. It's much expensive than the very advanced Wi-Fi AP already. And lower the price to the same level as other commercial Wi-Fi chip by taping out a real Wi-Fi chip. We are thinking about that, but we need to solve some issue before. We need to think something more clearly. For instance, well, we need the funding, right, to turn the FPGA into a chip. And the chip game is actually a game of volume. Go, no go decision depends on the volume, how big the volume we can achieve with the free Wi-Fi chip. If we tape out the chip, the very unique point of the chip will be that it's a free silicon and a free firmware. Is it unique enough to achieve a volume to make the chip profitable? To achieve the volume, I guess we need to be adopted by some very popular free software hardware project. Here, we definitely need your opinion. For instance, if some Raspberry Pi, some free Raspberry Pi, or some very popular hardware project could adopt a real open Wi-Fi chip, by collaboration, I think we can more or less partially solve the volume question. The most challenging question is the volume of the chip. So that's the end of my presentation. The dawn of the free liberal Wi-Fi chip. Does the world need a free Wi-Fi chip? Can we afford it? I mean, for the volume. Okay, questions?
Thank you very much, Xianjun, for the talk. It's great. We do have a couple of questions from IRC. Yeah, which I'll read back to you. So first, we have two questions by gnu+, who asks, yeah, Open Wi-Fi is AGPL v3. What does it mean in practice? What constitutes a service? Does the non-free PDK libraries count as system libraries?
The non-free PDK. I guess the PDK means the physical design kit of those chip foundry. We haven't thought that far because currently we are still working in the FPGA domain. Even in the FPGA, I think some of the module are not free because from FPGA vendor, from the third part, because like the software, the hardware design also has many building blocks. The licensing condition of all the components are complicated. We need to solve them step by step.
Right. Yeah, there's another question. Does Open Wi-Fi have non-free dependencies such as, a Xilinx toolchain or non-free Xilinx HDL blocks?
I think so. From Xilinx, from analog device, because this digital design domain is, I think, only recent years has rise a lot regarding the free and open source activity, not like the software move has started many years ago, started by the RMS. We are also just started. So we need to do things step by step. Currently, we make sure the core part, the Wi-Fi logic part developed by us is released under the AGPL v3. That's the part we can control. But definitely when we have energy and more resources, we will try to make the dependent part, non-free part, take some action there.
Thank you. Makes sense. And just to be clear for the people watching, my name is Amina Bandeli, and my nick on IRC is Bandeli. So if you join the LibrePlanet _room_Neptune room, you can ask questions and tag my nick, and then I will see the questions and ask them here. Okay, so we have another question by Alyssa, who asks, what are the legal issues around using Wi-Fi on FPGAs with respect to radio regulations like the FCCs?
Okay, currently, the situation is like this. For the regulation part, the user of the FPGA board should take the responsibility. For instance, during your okay, maybe there's a misleading part. I think in one of my slides, use the Open Wi-Fi AP at home. Yes, strictly speaking, you cannot do that right now because we haven't got the certification from the Wi-Fi Alliance and the regulation department of the government. But so now most of our activity, we do the cabling between our FPGA board and the commercial Wi-Fi chip and the test equipment to test our design. Yeah. So in principle, you shouldn't go to the air. That's true. Yeah, I thank you for the question. I have to remind all the people. Yeah, but that's the software-defined radio research going on. Not only our Wi-Fi design, actually those hardware, software-defined radio hardware are from Xilinx analog device. Lots of researchers did lots of other signal related research based on the software-defined radio platform. The platform are not manufactured by us. Open Wi-Fi is yet another design running on the commercial platform. The special thing of the design is that it's the first free Wi-Fi design. This year we have bought the very professional Wi-Fi tester, and we will do all the conformance test regards the regulation.
Awesome. Yeah, and that helps in part answer a question that someone else, Noisy Toot, had asked about how ready is Open Wi-Fi to use. Okay. Yeah, okay, let's see. So we have JROOTABGA, sorry, I can't pronounce the name, and who ask, since there's all this secret microcode, does that make the firmware significantly less useful, you think?
I think we do see a trend, especially in the Wi-Fi 6 area. Lots of vendors, they tend to put more and more functionality in the chip instead of in the driver and in the kernel. And below the firmware, there's a microcode. But firmware also play an important role, definitely. If some vendor could open the firmware, that's always very welcome and always a big step. But below the firmware, there's a microcode. So far, I don't see any action there. But firmware definitely play an important role because it's in between driver and microcode.
Gotcha. I think we have time for one or two more questions. So I'll ask them quickly. Let's see. So people are asking, multiple people have asked, do you know what kind of volume would be required to get the per unit cost of a free chip down to, let's say, $10 or within a reasonable amount?
Oh, yes, we did lots of work on that. I think at least it should be around at least 100K or 1000K, like million level, because that's the volume game. If we cannot achieve that volume, the chip could be quite expensive. Make things worse because it's chicken and egg. If we achieve a certain volume, the NRE, the research, the resource put before the tape out could be averaged to a very low level.
Understood.
Yes, but if someone from the chip industry could give us some guide or calculation on that, we will very appreciate.
Understood. Thank you. I think that's unfortunately all the time we're going to have for questions on stream. But Xianjun, if you're available on Freenode on IRC, you would very much appreciate it if you would take up the remaining questions on IRC.
Sure, you can find me via IRC JXJ. Okay.
Mm-hmm.
Nice. We are not online right now. Oh, okay. Our Wi-Fi chip, I have to say, it's currently it's still a very simple Wi-Fi chip. For the very complicated Wi-Fi chip, if you want that advanced functionality, and you should go for the very advanced Wi-Fi chip, not from us. Our Wi-Fi chip, as you can see, is still in the Wi-Fi 4 level. We are targeting Wi-Fi 6, but even Wi-Fi 6, there are lots of options. We need to start from the very basic option. So if you can live with Wi-Fi 4 or 6 with very basic option, I think you don't need reverse engineering anymore if you use our design. But if you need very advanced functionality and they are not open, so reverse engineering definitely also make big sense.
Thank you.
Thank you very much. Talk to you later.